Okay, let's solve for some x-intercepts. So let's write down y equals x squared minus 4x plus 3. And let's factor the right-hand side. So remember, two numbers that multiply to get 3 or add to get negative 4, negative 1 and negative 3. So make sure you print off the notes and do all the steps or highlight them or whatever, but we can factor it. So x minus 1 and x minus 3. Now, as it says in the English, in the sentence, solving for x-intercepts, the title, we want to solve for an x-intercept. And we know in the English instruction, far after the right, we want to factor it, then set y equal to 0. So we're going to put 0 in for y because we know that for an x-intercept, you can set 0 in for y. Graphing review. Now, if we're multiplying two things together, a and b, to get 0, then we know that each one of them can be 0 separately. So a could be equal to 0 or b could be equal to 0. We're going to call that the zero product principle or something. And we're going to use that so many times. So off to the left, I have two things multiplying together to make 0, so I can set them each equal to 0 separately. Then I can solve those equations. So teachers are going to rarely show you the steps anymore, like adding to both sides, but clearly look in the notes I have. So if you add 1 to both sides, x equals 1. Circle your answer. And the one on the right, if you add 3 to both sides, x equals positive 3. Then we can draw a graph. And what we know is we have an x-intercept at 1 and 3. And for all my parabola lovers out there, we know the vertex is here because we're a 1x squared, and we better have the pattern 1 squared is 1 and 2 squared is 4 symmetrical points. Also notice the y-intercept is positive 3 if we were to put x equal to 0 into that. So, get it equal to 0, factor it, set your brackets equal to 0 separately, and solve. Again, get it equal to 0, factor it, set your brackets equal to 0 separately, and solve. Okay, let's do another one. So y equals 2x squared minus 3x minus 2. Now, go back to grade 10 and learn how to factor these. So, two things that multiply together to make 2x squared has to be 2x and x. Two things that multiply together to make negative 2 are 1 and 2. And we have to do a negative 2 here because we have to multiply the 2x by the 2 to get negative 3x eventually. And we have to multiply the plus 1 by the x to eventually get negative 3. And the multiplication still has to work. So, put 0 in for y because we're looking for x-intercepts. Do the same method we did above. Set your factors equal to 0 separately. And solve. So, if we minus 1 from both sides, we get 2x equals negative 1. And if we divide both sides by 2, we get x equals negative a half. Circle your answer. And if we add 2 to both sides, let's skip that step. X equals 2. Then we can draw a graph. Now we have an x-intercept at negative a half and 2. That's not as pretty. I'm just going to draw it because all they asked for was our x-intercepts. Just sketching a parabola through it because we know it's an x squared. We know it's a 2x squared pattern, but we can't really recognize what it is. Either way, the steps. Get it equal to 0. If it's not, FOIL it out, distribute, combine like terms, do whatever is necessary to get it equal to 0. Second step, factor, and then using the AB equals 0 principle, set your factors equal to 0 separately and solve. Possibly draw it on a graph. Okay, so that's factoring and finding x-intercepts. What if it was a different form and you did a different factoring method? Well, they're the same as English instructions. Get it equal to 0, factor it, set your factors equal to 0 separately, and solve. Okay, so let's shrink that one up a bunch. Okay, so we are on the next page in the notes. Flip that page over and look at the next one in the notes. So I did another example like this. At the top, x squared minus 6x plus 5. I factored it. I set my factors equal to 0. I got my x-intercepts and I put them on the graph. Then, again, I did another one below it. Let's do a different type of factoring. Y equals negative x squared plus 4. So, I'm going to factor out the negative first. Y equals negative open bracket x squared minus 4. Then factoring it, y equals negative open bracket, differences of squares, x plus 2x minus 2. Go back to grade 10. So, set your factors equal to 0 separately and solve. Well, first of all, put 0 in for y because we're looking for x-intercepts. Now, this negative in front, it doesn't matter. Get rid of it. Divide both sides by negative 1. It's gone. Now, set your factors equal to 0 separately and solve. X plus 2 equals 0, and x minus 2 equals 0, and minus 2 from both sides, x equals negative 2, and add 2 to both sides, x equals 2. Check your answer. Put it back in and make sure it's true. Whichever. Draw the graph. So, we have a graph. We have x-intercepts at 2 and negative 2, like, excuse me, 2 and negative 2. Let's mark them, 2 and negative 2 and 2. I should have been marking them above. I'm going to mark them above. 1 and 3 and negative a half and 2. They should all have zeros after it, for that matter, but... So, no matter what type it is, factor it, set your factors equal to 0 separately, and solve. So I'm going to shrink this one up, and then it looks like I have to shrink the whole thing up a tad. And let's do one more at the bottom. Y equals negative x squared plus 2x. So put 0 in for y, looking for x-intercepts. Factor out a negative x. We're left with x minus 2. Now, set your factors equal to 0. It's easy to see this one. X minus 2 equals 0. But what to do with this one? Well, we just say x equals 0. And then we add 2 to the equation on the right. Excuse me. X equals 2. Circle both your answers. X equals 2 and 0. Draw it on a graph. So we have x-intercepts at 2 and 0. And draw your parabola. Maybe draw the rest of it with a table of values or figure it out. Oh, incorrect, incorrect, incorrect. Erase that. Sorry about that. The last two graphs, as we saw from last chapter, have negative coefficients. So they open downwards. So I forgot to draw the graph above. A parabola opening downwards through our two x-intercepts. And again, a parabola opening downwards through our two x-intercepts. Check your answer on your graphing calculator. That's what it's there for. Finding the x-intercepts. We're going to get to the calculator instructions for doing that.